Hello and welcome. Today we are going to solve inequalities with unknown in the denominator. Okay, when you look at the question here, solve x divided by x minus 1 less than or equal to 4 over x. Okay, we have prone numerals on both sides, okay, in the denominator. Right, now if this inequality work, this will work only when x not equal to 1 and x not equal to 0. Okay, so we have to remember that first. So now our question is x divided by x minus 1 is less than or equal to 4 by x. Okay, so now because it's inequality, I think I'm going to change the question to more than or equal to. Okay, I repeat, sorry. Solve x divided by x minus 1 more than or equal to 4 over x. Okay, now first what I'm going to do is I'm going to multiply by x minus 1 the whole square first. X minus 1 the whole square. And then this to avoid the x minus 1. So now I can write this as x divide times x minus 1 is more than or equal to 4 bracket x minus 1 the whole square by x. Now when you look at it, you have x in the denominator on the other side, right hand side. So what I'm going to do is I'm going to multiply both sides by x square. So when I do that, the next line is going to be x cube, because x square times x gives x cube, bracket x minus 1 is more than or equal to, one of the x gets cancelled, leaving with 4x bracket x minus 1 the whole square. So now what I'm going to do is I'm going to bring the whole thing to the left. So now the equation becomes x cube bracket x minus 1 take away 4x bracket x minus 1 the whole square more than or equal to 0. Now if you expand the thing bracket, it's going to be so complicated and then you won't be able to factorize back. Instead, we have to take anything common out. When you consider that, definitely both has x first, so I'm taking x out, and then both has x minus 1, I'm taking x minus 1 out, leaving with, in the first term, I have only x square left, take away 4, I've taken x already, one of the x minus 1 already, leaving with this more than or equal to 0. Now I'm going to simplify, expand and simplify the bracket. If I do, I think I made a mistake. No, not okay. So this becomes x square minus 4x plus 4 equal to, and then greater than or equal to 0. Now this can be factorized as x minus 2 the whole square. You have originally x and x minus 1, and this is more than or equal to 0. Now, you know, like questions like that, it is hard to solve. If it is equal to, the answer is so simple, but because it is more than or equal to 0, it is so hard to decide. You have to test so many regions. The best way to do is, if it is me, I prefer to draw the graph of y equal to x bracket x minus 1 bracket x minus 2 the whole square. I like to draw the graph first. From there, it is easy to decide the answer for the question. Okay, so this one, the graph, I'm just going to do the graph of, okay, I'm going to graph this. Now, first of all, this, the x-intercepts would be, x-intercepts for that graph would be x equal to 0, x equal to 1, x equal to 2, that's a double root. Okay, so this is a double root. Okay, so I'm not going to do a proper graph. I'm just going to do a kind of sketch that gives me an idea to decide the inequality. Okay, so now this is a fourth degree equation, and all I care about is the few values Okay, maybe I just take this as 0, this as, because I need 1 and 2, this as 1 and this is 2. I'm just worrying about these ones. The x-intercepts are, one is this, the other one is this, the other one is this, and this is the double root. And because it's a fourth degree equation, both the coefficient of x power 4 is positive, the graph goes like that. Okay, both ends facing the top. So if I do that, I'm just doing a rough graph. Now here it won't go down because it's double root, it bounces back. So the graph would be something like this. Okay, so this is the graph of y equal to x bracket x minus 1 bracket x minus 2 the whole square. What we need to know is what values of x gives you x bracket x minus 1 x bracket x minus 1 times x minus 2 the whole square more than or equal to 0. So that's the one we care about. So what I'm going to do is, in this part, because it's more than or equal to 0, these are the parts I need to shade. This is my answer. Because these are the values, but y would be more than or equal to 0, only on those values. Okay, so literally speaking, the answer would be, the solutions are, okay, the solutions, if I want to do that, one is x less than or equal to 0, because to the left of 0, the value of y is positive. But x cannot be 0, that gives you only one answer, which is x less than 0. That's one part. Now, then in between 1 and 2, between 1 and 2, x is again positive. Okay, so y is more than 0 in this region. But again, when you look at this question, x cannot be equal to 1. So here, x cannot be equal to 1. Therefore, the answer would be 1 less than x less than or equal to 2. Okay. Then, what happened is, at 2, it's all right. And then after 2 also fine. But then another third region is y more than or equal to 2. Okay. So the third region is y is 0 when x is more than 2. So that means, literally speaking, if you combine all the three, the solutions for the inequalities are, one, first x has to be less than 0, then x has to be between 1 and you can put 2, then x more than 2 as well. So all of them are solutions to the given inequality. Okay, so this is the one you have to decide. So this is